Hello everyone. In this tutorial, we'll look at how to set up materials and modifiers to achieve wireframe renderings of 3D models in Blender. These renderings are useful for showcasing your 3D models in online stores. In fact, in some cases, a couple of renderings of this type are explicitly required to demonstrate the topology and structure of your 3D models. The method shown in this tutorial is applicable to virtually all types of 3D models to be presented. This tutorial is a basic one and was created using Blender 3.3, but the modifiers and methods shown here have been available in several previous versions of Blender and, likely, will be in the future as well. Before we go on, I remind you that, as it happens with most of my tutorials, the text version of this video tutorial is available for free download at the link provided in the description. To provide a practical example, I'll be using a 3D model called Diner Boot Set 2. In particular, I'm using this 3D model because it contains several objects with different vertex and edge densities to be merged into a single object. Anyway, it is not necessary for you to have this 3D model. You can watch this tutorial and learn without having to download this 3D model. Okay, with the introduction out of the way, let's get started. The starting scene is actually quite simple. The only object initially inside it is the camera, which I have positioned to face the center of the scene from a high frontal angle. This view is not mandatory, but it generally works well, as 3D models are usually imported into the center of the scene, so a top frontal view allows, in most cases, to visualize different features of the models from the beginning. As for the output properties parameters, they heavily depend on the requirements of various online stores, so the resolution should be set according to the provided specifications. The virtual universe background can be conveniently set to black in the World Properties tab. Moreover, there are no light sources, because we will actually use two light-emitting materials to render our objects. For this reason, there is no need for a high number of samples for rendering in the Render Properties tab, nor to activate the denoise after rendering. I recommend creating images with transparency, using for instance the PNG RGBA format, so you can set the background as you wish at a later time. For this aspect too, different online stores may require different specifications. To prevent the background of Blender's virtual universe from being saved in the images produced by the rendering, open the Render Properties tab and select the Transparent option in the Film section. These are the starting scene settings, suitable for the vast majority of 3D models that you will need to render. Then import a 3D model into the scene using File, Append or Asset Browser, according to your preferences. As soon as it is imported, the Diner Boot Set 2 model is very large and does not fit within the frame. Before resizing it, however, I merge it into a single object with Join. Now, all the individual objects making up the set are selected, but there is no active object, so join cannot be performed correctly. To solve this issue, I press Shift and the left mouse button on an object, such as the central table, whose outline will change color to indicate that this is now the active object. I then press Ctrl J to merge all selected elements with the central table. I chose the central table as the object of joining because its origin coincides with the center of the virtual universe, making it easy to rotate or resize within the frame. If the model's origin does not coincide with the center of the virtual universe, you can still make it so by pressing Ctrl A and choosing Location from the Apply menu that will appear on screen. Now I can resize, move and rotate the model within the scene to achieve a good framing. To display the model's structure, we need to add a wireframe modifier, which initially makes the model's face disappear to show only the structure, but we can solve this problem simply by deselecting the Replace Original box in the Modifier tab. Before trying to set the thickness value, i.e. the thickness of the lines representing the structure, we must perform an important operation. Apply the scale transformations to the model, so that the thickness of the structure's lines is consistent with the units of measure of the virtual scene. To apply scale transformations, we select the 3D model, then press Ctrl A and choose Scale from the Apply menu that will appear on screen. Now we can adjust the thickness value to our liking, examining the preview in the 3D viewport, possibly zooming in on details to make sure we don't create lines that are too dense. We are not done yet, though. At this point, in fact, the 3D model still has its original materials and textures, as we can see by pressing the Z key and switching to Material Preview mode. In the Wireframe Modifier tab, we notice an interesting parameter, Material Offset. This parameter allows us to specify which material to use from an object's materials list to color or texture the edges generated by the wireframe modifier. This means that we can provide a white material for the entire object and then specify a second, black material to be used exclusively with the wireframe modifier, specifying one in the material offset parameter. The material will indeed be the second, but offset indicates the value to add to the first material index to get the desired one, and that's why we need to specify 1. To show how this happens, I'm changing the display mode of the 3D viewport to rendered. You will notice that, even though the object still has its original material, it will appear black, since the virtual universe of the scene is completely dark. Let's then move to the Materials tab of the object and remove all the materials there. In this case, there is only one, shared by all objects, but with other objects there might be several, depending on how many materials the imported and then merged objects add in the scene. Then let's add a new emission type material with pure white color and strength equal to 1, which will be provided to the entire object, making it white and clearly visible in all its parts from any angle, even if the scene is dark. Then let's add a second material, again of emission type with strength equal to 1, but this time of black color. In this way, we will get a material that will always be black with the same intensity, regardless of the angle of the shot or edges. To apply this second material to the geometries generated by the wireframe modifier, we go back to the Modifier tab and set 1 in the Material Offset field, as mentioned earlier. In the 3D viewport window, we can now examine the rendering preview and accordingly adjust the thickness parameter value, until we achieve a satisfactory result and start rendering. Once the first rendering is done, we could move the virtual camera in such a way to frame the model from other points of view, or, as in the case of the model examined in this tutorial, to frame the details, like the objects on the table, thus creating further renderings of the structure of the objects. If, instead of moving the camera, you decide to move, rotate, and resize the object, always remember to apply the scale transformations before modifying the thickness value and proceeding with the rendering. So, to recap, in this tutorial we have seen how to set up a simple Blender scene into which to import the 3D model of which we want to render the structure, known as the wireframe. We then saw how to merge several objects into a single object, so as to be able to transform and frame them more easily. We then looked at how to set up the only elements we need for rendering the structure, namely the wireframe modifier and the two emitting materials. Remember to apply the scale transformations to the model to get correct results with the wireframe modifier. I hope this simple tutorial was helpful to you. See you soon!